Hey you guys, so we're moving on with module 7 and looking at absolute value. So make sure that you're filling in the absolute value side of your notes. Um so absolute value, just as a reminder, is the distance a number is from 0 on the number line. So absolute value then is always going to be positive because it's a distance. So we use these bars to indicate absolute value, and because it's the distance from 0 on the number line, you're going to have two numbers that have the same, for any absolute value, you're going to have two numbers that have that absolute value, if that makes sense. So, for example, here, -4 has an absolute value of 4, as does +4. Oh, that's why I'm trying to draw on the screen and it's not drawing. So absolute value of -4 is 4, and the absolute value of +4 is 4. And just to illustrate why that is, if we have a number line and we have 0 here, if I go 4 units in either direction, 1, 2, 3, 4, that takes me to +4. But if I go backwards, 1, 2, 3, 4, that takes me over here to -4. So -4 is 4 units to the left, +4 is 4 units to the right. So they both have the same absolute value of +4. Now, just to get a little bit of practice with that, down here we have three pairs of numbers, -15, +15, absolute value of 25, and the absolute value of -25, and then the absolute value of -3 and +3. So if I do the absolute value of -15, the absolute value of -15 is 15. So is the absolute value of 15. What a lot of people I've noticed have wanted to do is to say, oh, well, if -15 becomes positive, then +15 must become negative. And that is not correct. It is always, always, always positive. Okay, so now +25 has an absolute value of 25, and -25 has an absolute value of 25. -3 has an absolute value of 3, and so does +3. What about something like the absolute value of 2.5? Well, 2.5 is 2.5 units from 0 on the number line, so the absolute value of 2.5 is just going to be 2.5. So whatever the number is, you just knock off, if there's a negative sign, you knock off the negative sign, and then that's it. Now, keeping with that idea that every absolute value, much like square roots, every absolute value has a positive version and a negative version. Like there's a positive number and a negative number that would have the same absolute value. So when we're solving an absolute value equation, we kind of have to think of it like we do with square roots, where we break it up into two equations. So the first thing I'm going to do here for x plus 3 equals 4 is I'm going to break that down into two equations. Because in order for this to come out to 4, I could have it equal to -4 or +4. So x plus 3 equals -4, and x plus 3 equals +4. So if x plus 3 were +4, it would have an absolute value of 4. And if x plus 3 were -4, it would have an absolute value of 4. All right, so I'm going to solve each of those equations separately. So x plus 3 equals +4. I'm going to subtract a 3 on both sides. And I get x equals +1. And then if I come over here and I subtract a 3 on this one, I'm going to get x equals -4 minus -3 is going to be a bigger negative, so it's going to be -7. So if we go back and we put those numbers back in, let's see how this works out. So if I make x equal to 1, the absolute value of 1 plus 3, that would be the absolute value of positive 4, which is 4. And then if I take my negative 7, and I do the absolute value of negative 7 plus 3, the absolute value of negative 7 plus 3 is going to be the absolute value of negative 4. And the absolute value of negative 4 equals positive 4. All right, so I'm going to erase where I checked so I have a little bit of room. So if you want to copy that down, pause real quick. Okay, so now let's do 2x minus 7. So I'm going to split that up again into two separate equations. So I'm going to do 2x minus 7 equals positive 5. And then I'm going to do 2x minus 7 equals negative 5. All right, so if I do the positive 5 first, I'm going to add a 7. So 2x equals 12. And then divide by 2, x equals 6. And I have room to divide by 2. So divide by 2. Okay, and now over here, I'm going to add 7 to both sides. A negative plus a positive, you subtract and then keep the sign of the bigger number. So that's going to be 2. So 2x equals 2, so x equals 1. So this statement right here, the absolute value of 2x minus 7 equals 5. 2x minus 7, its absolute value will equal 5 if x is 6 or if x is positive 1. And again, I'm going to have to erase this. So if you need to get it copied, or maybe I've got enough room. Yeah, I think I have enough room. Okay, so actually go ahead and try this one. Negative 3x plus 8 equals 20. You may get a fraction. You will get a fraction for one of your answers, I think. So go ahead and pause it for a second, try out this problem, and then come back and see how we work it out. All right, so first thing you should have done is broken this down into negative 3x plus 8 equals 20. I'm going to draw a line around here. Let me try that again. Got to move it over. Okay, negative 3x plus 8 equals 20. And then we're going to do negative 3x plus 8 equals negative 20. Okay. That didn't work out so good. That is going off the page. That's a 20. That's 0. There it is. Okay. So let's solve this first one, and then I'll squeeze that other one on there. So negative 3x plus 8 equals 20. I'm going to subtract 8 from both sides. So negative 3x equals positive 12. Then I'm going to divide by negative 3. And I get x equals negative 4. So that's one of my answers, is x equals negative 4. Okay, now let's see if I can get this other one. Okay, so I'm going to add 8 to both sides. So this time it's going to be negative 3x equals negative 28, because I'm going to add, or subtract 8, and subtract 8 from both sides, but because that's negative, I get negative 3x equals negative 28. So now when I divide by negative 3, I get x over here, but when I'm dividing two negatives, it's positive. So those negatives are going to go away. But 28 can't be divided by 3, so my answer is just 28/3. And that's the answer to that one. So if x is negative 4, this statement will be true. And if x is positive 28/3, it will also be true. Okay. Oops. All right. So now we need to solve and graph the solution. So I'm going to go kind of quickly through solving them because they're inequalities, but they're very similar to equations. But when we solve an absolute value inequality, we have to do an extra step. So I've got my first equation of x minus 5 is greater than 9. But because the negatives are like a mirror image of the positives, when I do my second equation, I'm going to flip that sign to face the other direction. So my second equation is going to be x minus 5 is less than negative 9. Because if I want my absolute value to be greater than 9, I want it to be numbers like 10, 11, 12. But in order to get that with a negative number, I need negative 10, negative 11, negative 12. So I want the numbers that are smaller than negative 9, because as we get smaller, the digits get bigger. So whenever we do this and we pull out we do the negative version, we just flip the sign around. So x minus 5 is greater than 9. I'm going to add a 5 to both sides. And so x is greater than 14. So I'm going to put that here first. Here's just going to put a 14 on here. And it's greater than, not equal to. So I'm going to have an open circle. And I want x to be bigger than 14. Well, where are the numbers that are bigger than 14? They're to the right of 14. So I'm going that way with my x is greater than 14. So now I want to do the less than negative 9. And so I'm going to add 5 to both sides again. But this time x is less than negative 4. Okay, so I'm going to put again, an open circle at negative 4. And I'm just drawing negative 4 in here. This is not to scale by any means. So I'm putting an open circle at negative 4. But this time I want x to be smaller than negative 4. And where are the smaller numbers? The smaller numbers are to the left of negative 4. So this arrow is going to go to the left. So those are the solutions to the absolute value of x minus 5 is greater than 9. All right, so let's do 2x minus 5 is less than or equal to 3. Okay, so I'm going to keep my first one. 2x minus 5 is less than or equal to positive 3. And then when I do the second one with the negative, I'm going to flip my sign around. I'm keeping the equal to symbol though. Okay, so 2x minus 5 is less than or equal to 3. I'm going to add 5 to both sides. So that's 2x is less than 8. And then divide by 2. X is less than or equal to 4. Okay, so I'm going to put a 4 right here. This time it is a closed circle. And where are the numbers that are less than 4? They are to the left. Okay, now 2x minus 5 is greater than 3, or greater than or equal to 3. So 2x minus 5, so I'm going to add, should have been negative 3. So 2x is greater than or equal to positive 2. So x is greater than or equal to 1. So 1 is, like, say, right here. And there's an open dot or a closed dot right there. And we're going to go this way. So now I got to figure out, like, where's the actual solution? Like, where are the numbers? Because there's some overlap there. So if I put in there a positive 5, that gives me 10 minus 5 is 5. The absolute value, so if I take a 5, let me get over here. If I take, that's my cat, by the way. if I take a 5 and I put that in here, I get 10 minus 5 is 5. The absolute value of 5 is not less than or equal to 3. Okay, so if I make x equals 10, if I make x equal to, or x equal to 5, 2 times 5 minus 5, that absolute value is 5, and it is not less than or equal to 3. So these numbers out here beyond 4 don't actually work. So I just want to go up to here. And then I want to check, let's try putting a 0 in there. If I put a 0 in here for x, I get 0 minus 5 is negative 5. The absolute value of negative 5 is 5, and that is not less than or equal to 3. So I actually can't use the numbers that are less than 1 either. So it turns out in these types of problems, I have to use the overlap. I have to use just this area here between 1 and 4, between my two solutions. Those are the only numbers that will actually work. Okay. Last problem here. So 4x minus 6 is greater than or equal to 8. And then when I do negative 8, I'm going to flip my sign around. So 4x minus 6 is less than or equal to negative 8. And then we're going to solve real quick and add 6 to both sides. So that's 4x is greater than or equal to 14. I'm going to divide both sides by 4. 14 fourths. So that is 7 halves. So I'm going to put 7 halves here on my graph. And x is going to be bigger than 7 halves. So I want, or equal to, so I want to close dot, and I want to go to the right where the numbers are bigger than 7 halves. Now, I'm going to solve the other one. I'm going to add 6 to both sides. So that's 4x is less than or equal to negative 2. So x is less than or equal to negative 2 fourths, which is negative 1/2. So I'm going to come over here, negative 1/2. And I'm getting a closed dot. That's 1/2. Getting a closed dot, and I want less than or equal to. So that'll be to the left. All right. So now let's look at a couple of word problems real quick. Okay. A healthy body temperature for a dog is considered 101 degrees plus or minus 1.5 degrees. So in other words, within 1.5 degrees of 101. Write an absolute value equation that represents the healthy temperature range for a dog. Now, you or I could look at this problem and say, oh, hey, within, if it went up as far as 102.5 or down as far as 99.5, that would be fine. But let's say we wanted to program an app or something to do this math for us. And we just wanted to punch in a button. And if it was outside, punch in the temperature. And if it were outside of a normal range, it would give us some sort of little warning signal or something. So I'm going to call T the body, the actual temperature. Okay. So the dog's actual temperature. What I want to do is I want to say, okay, if we take 101 and subtract the temperature, I want that value to be less than or equal to 1.5. So I want the difference between the healthy temperature and the actual temperature to be less than or equal to 1.5. The only problem is, what if it were more than 101? Let's say it were 102. So if I did this subtraction, if I did 101 minus 102, that's a healthy temperature. That's a 1 degree difference. That's a perfectly healthy temperature, but it's a negative 1. So what I want to do is just take the absolute value. I want to say, listen, It doesn't matter to me if it's above 101 or below 101. I just want the difference to be no more than 1.5. And so doing the absolute value like that will tell us, hey, if t is greater than 101 and it comes out negative, that's fine. We're just taking the absolute value. Okay, so let's look at another example down here. And feel free to pause and try this yourself. The weather forecast says there is a 50% chance of rain with a margin of error of plus or minus 2.5%. So a margin of error means they could be wrong in either direction, higher or lower by that much. Write an absolute value equation for the probability that it will rain today. So we're going to call P the probability of rain. Okay. And we're going to do just like we did with the body temperature. They're saying that it's 50. If we subtract the actual likelihood that it is going to rain, we want for that value to be less than or equal to 2.5. But since we don't care if it's higher, if it goes up to 52.5 or if it comes down to 47.5, we don't care whether the difference is positive or negative because it can go a little bit in either direction. So we're going to take the absolute value. Okay. So once you're done with this, I know this took a little bit of time. Do not go on to the solving quadratics notes. That will be hopefully tomorrow. But make sure that you have these notes copied down. Go back and rewatch if you need to. And we'll do a little bit of work with this on Tuesday when I come back.